Hi there. So now that we have talked about the basic chemistry and two types of chemical bonding, let's move on to something that is a little bit more familiar to us. Water. We have already earlier talked about evolution. We now know that ultimately, in an evolutionary sense, life began in water and over time developed to more complex forms, which eventually climbed on the land. So when scientists are searching for life on other planets, why are they usually looking for an evidence of water? Well, it turns out, in addition to our evolutionary past, most living organisms are mainly made of water. Even if you look at our planet from the space, the seas dominate the surface of the Earth. We truly live on a blue planet. Also, water has many unique life-sustaining properties, which all stem from the chemical structure of a water molecule. We will be looking at these properties of water a bit more later on. But before we do, let's figure out what about the chemical structure of a water molecule is so unique then. Earlier on, we learned about covalent bonds, where atoms shared some of their electrons so that they both would reach a state of having a full outermost shell. Well, this is the case also with a water molecule. Oxygen atom shares some of the electrons with two different hydrogen atoms. However, if you look at the shape of the structural formula written inside this space-filling model that you can see, you will notice that these letters are not written on a straight line. This is the key to understanding the unique characteristics of water molecule. So why is this case? Well, if you study the behavior of the electrons shared, you will notice that they spend more time around the oxygen than around the hydrogen. So the oxygen end becomes just slightly more negative, whereas the hydrogen end becomes slightly positive. A big deal, you say? Well, it is, and I will tell you why. We remember opposites attract each other. Well, when we have multiple water molecules, some have oxygen ends that are slightly negative, and some have hydrogen ends that are slightly positive. Now there is an attraction from one water molecule to another, and this is something that we know as hydrogen bond. It is a special kind of covalent bond, and this is why water has all these unique properties that it has. So on your textbook, you will read more about the properties of water, but the rest of this presentation will give you a brief overview of these. First of all, water dissolves many substances. In biology, we often call it universal solvent. This is due to its polarity and hydrogen bonding. There are hydrophilic substances which are attracted to water, and hydrophobic substances that avoid water. For example, earlier on we talked about sodium chloride, table salt, and it dissolves in water. See what a great solvent water is. Cohesion refers to water molecules' ability to cling to each other. Water molecules stick together. This is due to the hydrogen bonding. Adhesion, in turn, refers to the fact that water molecules cling to other polar surfaces. This is because of water's polarity. It is because of cohesion and adhesion that water makes an excellent transport system. Water transports, for example, nutrients and waste materials. And 90% of the liquid portion of the blood is water. Yet, when water is passed on vessels, the column that it forms does not break apart. Let's talk about the fact that water has a high surface tension. Water molecules at the surface cling more tightly to each other than to the air above. This is mainly due to the hydrogen bonding. As an example of this, which you can try out yourself, is when you slowly overfill a glass with water. You can make it form a small dome that extends above the top surface of the glass. This is because of the surface tension. Also, many bugs use this to walk on water. Now, let's talk about the ability of water to bind heat. We all know that the temperature of water changes rather slowly. It is because of the many hydrogen bonds that link the water molecules that water can absorb heat without greatly changing its temperature. As organisms that are made mainly out of water, this allows us to maintain our internal temperatures very stable and protects us against rapid temperature changes. Water also has a high heat vaporization. It takes a lot of energy to break the hydrogen bonds in water so that it becomes gas and evaporates. Heat is passed out as sweat evaporates from our body, which allows us to avoid our body temperature from rising too high in normal activities. Together, the high heat capacity and high heat vaporization result in a typically moderate temperature changes that we witness on the coastlines of the Earth, while these changes are often more drastic inlands. This is because oceans store and release the heat slowly, therefore evening out the changes. Finally, let's talk a little about what may happen if you put a soda bottle in a freezer. You might have a rather unpleasant surprise, something like these pictures waiting for you. Why is this? Well, water expands as it freezes, but this has another important consequence. Since water expands as it freezes, it becomes less dense than the liquid water. This explains why ice floats on liquid water. And this is why fishes can survive in lakes throughout the winter, while it may appear to us that the lake has frozen over. In fact, the bottom of the lake is still liquid, and even more, ice acts as an insulator. I think that this is a good time for us to take a break now. Next, we are going to talk a little bit about acids and bases. See you then!